Continue with the basics. So in the previous session, we have discussed what is NCR. Okay. So the formula for NCR is nothing but n factorial by r factorial into n minus r whole factorial. And we have also computed NCR, like we have computed 50C2. Okay, it is 50 into 49 by 2. And we have proved that NCR is equals to NC n minus r, right? And also we have proved that product of r consecutive integers is divisible by r factorial, right? So now let us discuss the basics of binomial theorem. So it is a big chapter in its own, but now we are just going to touch its basics. So let us say you have a plus b whole square. You know the formula for this, right? It is a square plus 2ab plus b square. Let us say you have a plus b whole cube. Then you know formula for this also. That is, it is a cube plus 3a square b plus 3ab square plus b cube. Now say if I ask you to expand a plus b whole power 4, okay, then I mean somehow you can square this and you can tell me the answer, okay, but it will take some time. And if I ask you to expand a plus b whole power 5 and so on, then I mean we need to develop something, some formula or some method to expand this higher powers of a plus b. Okay, so that formula is given by binomial theorem. That formula itself is called as the binomial theorem. Binomial means there are only two terms, a and b. That's why the name binomial. Okay, so let us expand this. So a plus b whole power 4, it is equal to 4c0 into a power 4 plus 4c1 into a cube b. Okay, now when the highest power of a is 4, then one power of a reduces and one b appears. Okay, then plus 4c2 into a square b square. Okay, one power of a decreases, that is a cube becomes a square, and one power of b increases, b becomes b square, plus 4c3 into a into b cube. The same thing is going on, right? One power of a decreases, one power of b increases. Here power of a was 2, now it is just 1. Here power of b was 2, now it has increased to 3. And finally plus 4c4 into, now it is a power 0, so it is basically 1, and b power 4. Okay, so you can see that 4c0, 4c1, 4c2, 4c3, 4c4, this is the pattern. And we started with a power 4, right? The highest power of a can be 4. And then in the subsequent terms, you can see that power of a decreases by 1, whereas power of b increases by 1. Here it was b power 0, so here it is b power 1, then it is b power 2, b power 3, and b power 4. And you can see that power of a continuously decreases by 1. Okay, so it is a power 0. So this is how we expand a plus b whole power 4. So we know the value of 4c0. 4c0 is 1, right? In fact, nc0 is 1 for any n. So it is a power 4 plus 4c1 is 4. nc1 is 1. So it is 4a cube b plus 4c2, you can compute it. It is 6 plus 6 a square b square plus 4c3 is equal to 4c1 because NCR is nc n minus r. So 4c3 I can write it as 4ab cube plus 4c4 is nothing but 1 plus b power 4. So this is the formula for a plus b whole power 4. Okay, so how this formula was derived, that thing we will discuss when we study binomial theorem or combinatorics in detail. But for now, you just remember how to expand this higher powers of a plus b. Okay, so this is the way you can expand a plus b whole power 4. Now let us do it for a plus b whole power 5. Fine, so a plus b whole power 5 will be 5c0 into a power 5, right? Because now the power is 5, so the terms will be 5c0, 5c1, 5c2, 5c3, and so on. And the highest power of a will be 5, plus now it will be 5c1. Power of a will be decreased by 1, power of b will be increased by 1. Plus it is 5c2 into a cube b square plus 5c3 into a square b cube plus 5c4 into a into b power 4 plus phi c phi into b power 5. Right? You can see that power of A is continuously decreasing by 1, whereas power of B is increasing by 1. Okay. So you keep writing the notes along with me. Okay. I accept that our speed is a little bit higher because the concepts are new to you, but try to cope up with the speed. Okay. Since the syllabus is vast, we need to maintain a little bit higher speed, and also we need to discuss deep questions. Okay, tough problems. So you try to cope up with the speed and keep writing the notes along with me. Fine. So this is how we can expand a plus b whole power 5. Right, now let us just put the values. Value of phi c0 is 1, so it is a power 5. Phi c1 is nothing but 5, so it is phi a power 4 into b, plus phi c2. Phi c2 is 10. You can compute it. It is 5 factorial by 2 factorial 3 factorial. So 10 a cube b square, and phi c3 is nothing but equal to phi c2 because NCR is NCN minus R. So it is 10 a square b cube, plus phi c4 is again phi a b power 4, plus phi c5 is 1. So it is b power 5. So this is the expansion of a plus b whole power 5. Okay. So similarly, you can expand a plus b whole power 6. That will be 6c0 into a power 6 plus 6c1 a power 6 b plus 6c2 a power, sorry, the power of a will be decreased by 1. So a power 6 will be become a power 5. A power 5 will become a power 4. Then it is b square. 6c3 a cube b cube. The power of a is decreasing by 1, whereas the power of b is increasing by 1. Plus 6c4 a square b power 4 plus 6c5 a b5 and plus 6c6 b power 6. So now 6c0 is nothing but 1. So it is a power 6 plus 6 a power 5 into b plus 6c2, it is 6 into 5 by 2. Right? This is how we compute 6c2. So that will be 15. Okay, so I'm writing it directly. It is 15 a power 4 b square plus 6c3, you can compute it. It will be 20 a cube b cube plus 6c4 is again equal to 6c2, so that is 15 a square b power 4 plus 6c5 is again 6, so it is a b power 5 plus 6c6 is equal to 1, so plus b power 6. So this is how we expand a plus b whole power 6. Okay. So now let us say if you want a minus b whole power 4. Okay. So then instead of plus b in this formula, you can replace b with minus b. You will get a plus b, a minus b whole power 4. Right. So I mean you can treat it as a plus minus b whole power 4. Right. So then this will be a power 4, 4c0 into a power 4 plus 4c4 into a cube into minus b plus 4c2 into a square into minus b whole square plus 4c3 into a into minus b whole cube plus 4c4 into minus b whole power 4. Right. So I mean minus b we are treating it as second term, that is b. So this is a plus this entire thing is b. So we have written that formula of a plus b whole power 4. So now let us just put the value. So 4c0 is 1, so a power 4 minus 4a cube b plus 4c2 is 6, so plus 6a square b square, because minus b whole square is anyways positive, positive of b square, and minus 4ab cube, and you'll get plus b power 4. So this is the value of a minus b whole power 4. So in the formula of a plus b whole power 4, if you replace b with minus b, you will get the same thing. Okay. So this is how you can expand a minus b whole power 4. Okay. So let us say if I ask you to expand say x plus 3 whole power 5, then it is simply phi c0 into x power 5 plus phi c1 into x power 4 into 3. Now instead of b we have 3 and instead of a we have x. So it is a plus b whole power 5. So phi c0 x power 5 plus phi c1 into x power 4 into 3 plus 5c2 into x cube into 3 square, right? Plus 5c3 into x square into 3 cube plus 5c4 into x into 3 power 4 plus 5c5 into 3 power 5. So this is the expansion of x plus 3 whole power 5. So just a is replaced by x and b is replaced by 3. The pattern is same, right? You try to remember the pattern. So 5c0, 5c1, 5c2, 5c3, 5c4, 5c5, because the power is 5, and since the highest power of x is 5, it will start with x power 5, and the power of x will be decreasing by 1, whereas the second term, that is 3, will be increasing by 1. So here it was 3 power 0, now it is 3 power 1, 3 power 2, 3 power 3, 3 power 4, and 3 power 5. So this is how you expand this x plus 3 whole power 5. Suppose I ask you to expand 1 minus 2x whole power 4. So then it is nothing but 4c0, right, into 1 power 4 plus 4c1 into 1 cube into minus 2x plus 4c2 into 1 square into minus 2x whole square plus 4c3 into 1 into minus 2x whole cube plus 4c4 into 1 power 0 into minus 2x whole power 4. So this is how you can expand 1 minus 2x whole power 4. Here a is 1 and b is minus 2x. Okay, we are treating this as 1 plus minus 2x whole power 4. So then we have followed the same principle. 4c0, 4c1, 4c2, 4c3, 4c4, and we have started with 1 power 4, and then the power of 1 is decreasing and the minus 2x is increasing by 1, 2, 3 and 4. Okay, it is increasing by 1. So in this way you can, expand any binomial expression. Suppose if I ask you to expand x plus 3 whole power 7, then also you can do, but it might take a little bit of time. So you can expand 1 plus x whole power 5 and all these things you can do it. Okay. So now, let us observe some things in this expansion. So you can observe that in this expansion of a plus b whole square, how many terms are there? Okay, terms means unlike terms. Okay, suppose if I have a plus 3a, so this is not two terms, this is only one term because this is 4a. Okay, this is only one term. So if I have a plus 3a square, then these are two terms because these two terms are unlike. So these we count as two terms. Okay, but this is only one term, not two terms. Okay, so terms means what? It is unlike terms. So all these terms are unlike, right? So in a plus b whole square we have how many terms? 3 terms. In a plus b whole square we have 3 terms. In a plus b whole cube you can see we have 4 terms, right? In a plus b whole power 4 you can see we have how many terms? 1, 2, 3, 4 and 5 terms, right? So in a plus b whole power n you will have how many terms? N terms. Okay, so this is the general pattern which we can observe. So why is it so? Because terms are starting with a power 4, right, and then it goes till a power 0. So all the terms are there with a power 4, a cube, a square, a power 1, a power 0. So the number of terms is 4 plus 1, that is 5. Okay, and also you can observe that in every term, what is the sum of powers of a and b? Okay, so here 3 plus 1 it is 4, 2 plus 2 it is 4, 1 plus 3 it is 4, here it is 4. So sum of powers of a and b is 4 in any term. Similarly, you can observe in this expansion, sum of powers of a and b is 5 in any term. So here it is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and it is 5. So in any term, the sum of powers of a and b is how much? It is 5. So now let us just generalize this. Okay, so let us generalize a plus b whole power n. Okay, so a plus b whole power n will be what? nc0 into a power n. Okay, instead of a plus b whole power 4, 5, now just I have written n. Okay, and n I am treating it as natural number. Okay, so it is nc0 whole power into a power n plus nc1 into a power n minus 1 b, right? The power of a decreases by 1, the power of b increases by 1, plus nc2 into a power n minus 2 into b square, plus nc3 into a power n minus 3 into b cube, plus so on. And I mean, general term, you can see that nc3 a power n minus 3 b power 3, nc1 a power n minus 1 b power 1, nc2 a power n minus 2 b power 2. So if there is ncr, it will be a power n minus r b power r, right? So you can observe the pattern. If there is nc1, it is a power n minus 1 b power 1. If there is nc2, it is a power n minus 2 b power 2. So if there is ncr, then it will be a power n minus r b power r, and plus so on, so on. The second last term will be what? It will be nc n minus 1 a into b power n minus 1, and the last term will be ncn into b power n. Okay, so this is the general expansion for a plus b whole power n. Okay, I think it is very easy to observe because we have already done so many examples, right? We have expanded a plus b whole power 4, whole power 5, whole power 6. Then we have also expanded x plus b whole power 5. So you can clearly observe that a plus b whole power n will be in this way, right? So now in this we can see that number of terms is equals to n plus 1, right? Because the power of a is starting from a power n minus 1 to a power 0. So there are 0, 1, 2 up to n. So there are n plus 1 terms. Okay. And in each term, you can notice that sum of powers of a and b, is equals to n, right? In each term, if you add the power of a and b, it will be n. N minus 2 plus 2 is n, n minus 3 plus 3 is n, n minus r plus r is n, and so on. Okay. So this is the basic expansion of a plus b whole power n. And similarly, I mean, you can expand a minus b whole power n, right? We can generalize a minus b whole power n. This will be nc0 a power n minus nc1 into a power n minus 1 into b, plus nc2 into a power n minus 2 into b square, minus nc3 a power n minus 3 b cube, and it will be going so on. And you can see that if there is nc1, the sign is negative. If there is nc2, the sign is positive. If there is nc3, the sign is negative. So if there is ncr, okay, then a power n minus r b power r, what will be the sign? It will be minus 1 whole power r, right? If r is odd, the sign will be negative. If r is even, the sign will be positive, and plus so on. Finally, we'll get minus 1 whole power n into ncn into b power n. Okay, so this is the general expansion of a minus b whole power n. Fine. So now let us observe the special expansion of 1 plus x whole power n. Okay, so let us, I mean, use the formula for a plus b whole power n only. So you will get nc0 into 1 power n plus nc1 into 1 power n minus 1 into x plus nc2 into 1 power n minus 2 into x square plus nc3 into 1 power n minus 3 into x cube plus nc4 into 1 power n minus 4 into x power 4, and plus so on. The second last term will be nc n minus 1 1 power n minus of n minus 1 into x power n minus 1, and plus ncn 1 power 0 x power n. Okay, so now you can see that 1 plus x whole power n is nc0, I'm writing it as it is, and I mean 1 power n, 1 power n minus 1, all these terms are nothing but equal to 1. So it is nc0 plus nc1 into x plus nc2 into x square plus nc3 into x cube plus so on plus ncn into x power n, and any general term will be ncr x power r, right? So this, I mean, you need to remember specially because it will be appearing in many problems. Okay, so it will be appearing so many times. So you need to remember 1 plus x whole power n as you have remembered a plus b whole power n. So similarly 1 plus x whole power n you need to remember. Okay, so if I ask you 1 minus x whole power n, then this will be Just replacing x with minus x, right? You replace x with minus x in this equation. nc0 minus nc1 into x plus nc2 x square minus nc3 x cube plus nc4 x power 4 and so on. You'll get minus 1 whole power n ncn into x power n. So this is the expansion of 1 minus x whole power n. Okay. So now, I mean, these are the little bit of basics of binomial theorem. When we study binomial theorem separately, we'll discuss in depth. But for now, these things, if you remember, then it is fine. This will be helpful both in number theory and in algebra as well. Okay. So let us see a small example. Say you have, I mean, let us see first an example of 1 plus x whole power 6. Okay, so this is nothing but 6c0 plus 6c1 into x plus 6c2 into x square plus so on plus 6c6 into x power 6. Okay, now say x is a multiple of 3. Okay, x is a multiple of 3. Then what is the remainder? What is the remainder obtained on dividing 1 plus x whole power 5 with 3, okay, or by 3. So I hope, I mean, you already know what is a remainder, what do you mean by a multiple of 3. These things are pretty basic, so I assume that you know this. Okay, so x is a multiple of 3, right? X is a multiple of 3 means what? Then x can be, it can be 3, it can be 6, it can be 9, 12 and so on. Also, I mean, we can consider negative numbers, minus 3, minus 6, minus 9, minus 12 and so on. And also it can be 0. Okay, so x can be 0 plus minus 3 plus minus 6 plus minus 9 plus minus 12 and so on. These are the possible values of x. So if x is a multiple of 3 and if there is 1 plus x whole power 5, okay, now if you divide this 1 plus x whole power 5 by 3, what will you obtain as remainder? Okay, that is the question. So what we do is we just expand it. So this is 5c0 plus 5c1 into x plus 5c2 into x square plus so on plus 5c5 into x power 5. Okay, so now observe this thing that if x is a multiple of 3, if x is a multiple of 3, then I can write x as some 3 into k, right? Where k is also integer. Okay, where k is a integer. So since x is a multiple of 3, I can write x as some 3 into k, right? I can write x as some 3 into k. Now this 1 plus x whole power 5 is nothing but 5c0 plus 5c1 into x. X is nothing but 3k. So I'm just putting x is equals to 3k in this equation. Okay, plus 5c2 into 3k whole square. Okay, plus so on plus 5c5 into 3k whole power 5. So 5c0 is 1 plus, see, 3k, 5c1 into 3k, this is definitely a multiple of 3, right? Because it is 3 times some integer. 5c1 is integer, k is integer. So it is 3 times some integer. This is a 3 square times integer. So it is definitely a multiple of 3. So all these terms, you have at least one 3 in them. So all these terms are multiples of 3. So I can write this as 3 times some another integer, say m. Okay, where m is an integer, right? So this step is very important. So 5c1 into 3k is a multiple of 3 because there is 3 in this, right? You can write this as 3 into 5c1 into k. So this is an integer because both 5c1 and k are integers. Similarly, 5c2 into 3k whole square. So 3k whole square, you can take 3 common and you will get 3 into 5c2 into 3k. So this is also a multiple of 3. So similarly, you will have 5c3 into 3k whole cube. Okay, this is also a multiple of 3 because there is 3 in this. And you will have 5c4 into 3k whole power 4. This is also a multiple of 3. And this is also a multiple of 3. So this entire thing I can write it as 3 into some m, where m is an integer. So this entire thing is a multiple of 3. So now this is what 1 plus 3m. Okay, where m is an integer. This is the value of 1 plus x whole power 5. So m is an integer. This is the value of 1 plus x whole power 5. Now, what will be the remainder when I divide this 3m plus 1 with 3? The remainder is 1. Right? The remainder is 1. Because 3m plus 1 means what? It is like 4, 7, 10 and so on. Right? If you put the values of m as 1, 2 and 3, you will get these numbers. So if you divide 3m plus 1 with 3, you can see that 3m is 3m and we'll get 1 as remainder, m as quotient. Okay, so 3m plus 1, if you divide with 3, you will get 1 as remainder. So the answer is 1. Okay, so this is the way in which binomial theorem will prove helpful to us while solving problems. Okay, so that's why we have just gave a brief idea of how to expand a plus b whole power n, how to expand 1 plus x whole power n. Okay, fine. So let us do one more thing, one more question. Say, what is the remainder on dividing 1 minus x whole power 3, 1 minus x whole power 3 by 5, okay, and it is given that x is a multiple of 3. It is given that x is a multiple of 3. Okay, so this is given. So we can do it by the same technique, right? Since x is a multiple of 3, I can write x as some 3k where k is an integer. Okay, so x can take the value 0, plus minus 3, plus minus 6 and so on. So 1 minus x whole cube, let us expand this. So this is 30 minus, it is 3c0 minus 3c1 into x plus 3c2 into x square minus 3c3 into x cube. Right, so this is 1 minus 3c1 into x is 3k plus 3c2 into x square is 3k whole square minus 3c3 into x cube is 3k whole cube. So this is again 1 plus, you can say that 3 into some integer. Okay, so this integer may be positive or may be negative, that doesn't matter, but this is 3 into some integer where m is an integer, right? So this is 3 into m where m is an integer, because in everything you can say that 3 is common, and you'll have minus 3c1 into k plus 3c2 into 3k square left over if you take 3 common. So this is 3 into m. M may be positive or negative. Okay, so m may be positive or negative, that we don't know, but we can say that this is 3 times m where m is an integer. So then 1 minus x cube is also 3m plus 1. So if you divide this with 3, okay, the remainder will be what? Remainder will be 1. Fine, is it clear? Yes. So I hope this thing is clear. So we have just discussed how to expand a plus b whole power n and 1 plus x whole power n. Now let us discuss some more basics. Okay. So let us discuss how to solve a quadratic equation. Okay. How to solve a quadratic equation. Okay. This is what we are going to discuss. I mean, this thing also we'll discuss in detail, in depth, when we study purely quadratic equations and expressions. But now you must have a small idea of how to solve any quadratic equation. Okay. Suppose if I give you x square minus 7x plus 12 is equals to 0, then you can, I mean, easily solve it. You can factorize this as x square minus 3x minus 4x plus 12. Okay, and then you will get as x minus 3 into x minus 4 is equals to 0. Then you will say that the roots are 3 and 4. Okay, so x is equals to 3 and x is equals to 4 both satisfies this equation. Okay, so this has this has two real roots, that is 3 and 4. Fine, but every time this is not factorizable. Okay, so how to solve this quadratic equation at that time? Okay, so quadratic equation always has two roots. Okay, just like a linear equation 3x plus 5 is equals to 0, it has one root minus 5 by 3, but a quadratic equation always has two roots. So let us try to solve one question. Say you have x squared plus x squared plus x minus 1 is equals to 0. Okay, this is a quadratic equation. Now how will you solve this equation? You can see that you can't factorize it. Okay, because the one the coefficient of x is plus 1. You can't express this in two numbers whose product is minus 1 and whose sum is plus 1. So it is not factorizable that easily. So what do we do is we complete the square. So let us see how do we complete the square. So we have done this type of question earlier. So this is x square plus x, right? So I want to express this as some x plus constant whole square. So I know that x plus constant whole square is x square plus 2kx plus k square. Fine. So you can see that x square is matching, and this x, instead of this x, you can compare this with 2kx. So if we want to express this as perfect square, what we will do is we write this as x square plus 2 into 1 by 2 into x, right? Because this is 2ab, so you have 2, you have x, and then to maintain uniformity you just divide with 1 by 2. Okay, so now you have got x square plus 2x into 1 by 2. So you just add 1 by 2 whole square and you subtract 1 by 2 whole square, and you write minus 1 as it is equal to 0. So now this entire thing, it is what? A square plus 2ab plus b square. So it is a plus b whole square, and it is minus 1 by 4, minus 1 is equals to 0. So then I can write x plus 1 by 2 whole square as minus 5 by minus 1 by 4, minus 1, it goes to that side, it is plus 5 by 4. So then x plus 1 by 2 is how much? Plus minus square root of 5 by 4, right? We have seen earlier that if x square is 4, then x is plus minus square root of 4. But if I ask you the value of root 4, it is just 2. Okay, it is not minus 2. Fine. So in a similar way, x plus 1 by 2 whole square is 5 by 4. Then I can write x plus 1 by 2 as plus minus square root of 5 by 4. So then I can say that x is minus 1 by 2 plus minus square root of 5 by 4. So one root of this equation is minus 1 by 2 plus root 5 by 4, and other root is minus 1 by 2 minus root 5 by 4. So there are two values of x which satisfies the original equation. You can check this by squaring this. Okay, you can verify this whether this satisfies the equation or not. It will definitely satisfy. Okay, so there are two values. One is minus 1 by 2 plus root 5 by 4. Other is minus 1 by 2 minus root 5 by 4. Fine. So let us solve one more question. Say you have x square plus 3x and plus 1 is equals to 0. So you can pause the video and try the problem on your own. Then we'll discuss. So let us begin solving it. So again, I will try to complete the square. Okay, I will try to complete the square. So how do you complete the square here? So it is x square plus, we want this as 2ab. So 2 into x into, now to maintain uniformity, you will write 3 by 2 here, right? Because 2 into x into 3 by 2 is nothing but 3x, and we have got our form 2ab. Now we just add b square and subtract b square. Plus 1 is equals to 0. And now we have completed the square. That's what we are talking about, completing the square. So this is x plus 3 by 2 whole square minus 9 by 4 plus 1 is equals to 0. So then I can write x plus 3 by 2 as 9 by 4 minus 1, which is nothing but 5 by 4. So then I have got x plus 3 by 2 is plus minus square root of 5 by 4. So then x is nothing but minus 3 by 2 plus minus square root of 5 by 4. Okay. So this is how you solve a quadratic equation which you can't factorize it. Okay. If you can factorize it, it is well and good. But if you can't factorize it, you can complete the square and you can solve a quadratic equation. Yes. So let us move ahead. Say now, if I have given you a general quadratic equation, ax square plus bx plus c is equals to 0. Fine. I have given you a general quadratic equation, ax square plus bx plus c is equals to 0. Then how do you solve it? Okay, so the same method, we just try to complete the square. So whenever we are trying to complete the square, we make sure that the coefficient of x square is 1. Okay, we make sure that the coefficient of x square is how much? 1, because then only we can write it as x plus some constant whole square, right? X plus constant whole square is x square plus 2kx plus k square. So here the coefficient of x square is how much? It is 1. Okay, so we make sure that the coefficient of x square is 1. So we do the same thing here. We just divide the entire thing by a. So it will be x square plus b by a into x plus c by a is equals to 0 by a, which is nothing but 0. So I've divided entire equation with a. So what we have done, we have made coefficient of x square as 1. We have made coefficient of x square as 1. Now we follow to complete the square. Okay. So here it is x square plus b by a into x. Okay, these terms are constant. This a, b, c are what? These are constants. So you write it as x square plus 2 into x into, now you want b by a. So you write b by 2a, right? If you write 2 into x into b by 2a, you'll get b by a into x. Now you can see that it is x square plus 2 into a into b. So you just add b by 2a whole square and you subtract b by 2a whole square. And you just take this plus c by a as it is. So then this entire thing is how much? It is x plus b by 2a whole square. This is equal to b square by 4a square minus c by a. So these terms have taken to this side. So then you can see that this is x plus b by 2a whole square is nothing but taking 4a square as LCM. I'll get b square minus 4ac. So then I can say that x plus b by 2a is nothing but plus minus square root of b square minus 4ac by 4a square, right? So then I can write x is nothing but minus b by 2a plus minus square root of b square minus 4ac by 4a square. So square root of 4a square is also equal to 2a, right? So then I can write it as minus b plus minus square root of b square minus 4ac over 2a. Okay, so this is how you solve for x. Okay, so you just remember this formula. If you remember this formula, then you need not complete the square always, but you should also, remember this idea of completing the square. It will help us in some problems. Okay, so you just remember how to complete the square, and also you remember the formula, so that by formula you can solve it directly. For example, let us take x square, let us take 3x square plus 2x minus 5 is equals to 0. So I'm just using the formula here. if we compare it with ax square plus bx plus c equals to 0, I can see that a is equals to 3, b is equals to 2, and c is equals to minus 5 here. So then what is the value of x? X is nothing but minus b plus minus square root of b square minus 4ac by 2a. So this is minus 2 plus minus square root of b square. B square is 2 square minus 4 into a is 3 and c is minus 5 divided by 2 into a is 3. So this is x is equals to minus 2 plus minus square root of 4 plus this is 4 3 is 12, 12 5 is 60 by this is 6. So this is minus 2 plus minus square root of 64 is 8 divided by 6. So one answer is minus 2 plus 8 by 6. Other answer is minus 2 minus 8 by 6. So this is 1 and this is minus 10 by 6, which is minus 5 by 3. So I think, you can solve this by factorizing also, right? Because this is minus 15. You can express 2x as plus 5x and minus 3x, and then also you can solve it. But we have also seen how to solve using the formula. Fine. So this is how you solve a quadratic equation. Okay, let us consider one more example. Say you have x square plus x plus 2 is equals to 0. So carefully try to listen this example. Okay, you can pause the video and try to solve it on your own. Fine, let us begin solving this. So listen it very carefully. We'll introduce one concept here. We are going to introduce what is a complex number. So just listen very carefully. So if I solve this using the quadratic formula, that is minus b plus minus square root of b square minus 4ac by 2a, you can see that here a is equals to 1, b is equals to 1 and c is equals to 2. So let us just put the values. Minus b plus minus square root of 1 square minus 4 into 1 into 2 by 2 into 1. So this is minus 1 plus minus square root of 1 minus 8 by 2. So this is minus 1 plus minus square root of minus 7 over 2. So you see here you are getting square root of minus 7 over 2. So, but we know that square root of minus 7 is meaningless, right? So until now we have studied square root of x, then x should be positive. Okay, that is what we have studied until now. So we know that square root of 3 is defined, square root of 5 is defined. So these are irrational numbers, right? We have studied about irrational numbers. So you can write square root of 2.1, you can have square root of 5, you can have square root of 4, but square root of minus 4, this is something unusual. We have not encountered this before, right? What is square root of minus 4? Okay, so this is a complex number. Okay, so now let us introduce what is a complex number and what is an imaginary number. So we define square root of minus 1 as iota. Okay, this is denoted by iota. This is denoted by I and it is read as iota. Okay, so you can also read as I, it is no problem, but you can also read it as iota. The square root of minus 1 is iota. That is how we define a complex number. Suppose this iota is root of x square is equals to minus 1. We have earlier discussed that a square of a real number is always non-negative, right? That is what we have discussed earlier when we were discussing about a square plus b square plus c square minus ab minus bc minus ca. We have discussed that square root of a real number is always non-negative, right? This is true if x is real number, that is x belongs to the set of real numbers. But x square can be negative if x belongs to complex numbers, that is the set of complex numbers. So if x square is equals to minus 1, then I can write x is equals to plus minus square root of minus 1. Okay, so square root of minus 1 is denoted as iota. Fine. So iota square is what? Minus 1. So this is a basic introduction of complex number. I mean, there is nothing to worry about this, and we'll just need very basics of this, so that we'll use in some problems in algebra. So iota square is how much? It is -1. So similarly, minus root -1 is nothing but minus iota, because root -1 is iota. Okay. So suppose now you have root over -4. This you can write it as root -1 into 4. So this you can write it as root -1 into root 4. So this is iota and this is 2. So this is nothing but 2 iota. Suppose you have root over -3. So this you write it as root -1 into 3, and this is root -1 into root 3, and this is iota into root 3. So this is root 3 iota. Fine. So if you have root -17, this is nothing but 17 iota. So let us come back to our problem. X square plus x plus 1 is equals to 0. We were solving this equation, right? And we got x as -1 plus minus square root of 1 minus 4, which is -3 over 2. So this is nothing but -1 plus minus 3 iota over 2. So one value is -1 plus 3 iota over 2, and the other value is -1 minus 3 iota over 2. Fine. So what is iota? It is nothing but iota square is -1. This is important. This is what you need to remember about iota. So this is an imaginary number. So iota is nothing but imaginary number. Fine. Suppose you have, if you have 2 iota or 3 iota or minus root 5 iota or root 5 iota, these are all purely imaginary numbers. These are all purely imaginary numbers. But if you have, say, 1 plus iota, 3 plus 2 iota, 7 plus 6 iota, these are called complex numbers. These are called complex numbers. Okay. Suppose if you have 3 plus 2 iota, then if x is, say, 3 plus 2 iota, then the 3 is called real part of x. 3 is called real part of x, whereas this 2 is called imaginary part of x. 2 is called imaginary part of x. So here x is what? It is a complex number. It is not real number. So a complex number has two parts, real part and imaginary part, right? So if it is 3 plus 2 iota, then 3 is the real part and 2 is the imaginary part of this. And if real part is 0, as in 2 iota, you can write it as 0 plus 2 iota. So the real part is 0, then the number is purely imaginary number. Fine. So this is about real part and complex part or imaginary part. Say if you have x is equals to 5 minus 7 iota, then 5 is real part and minus 7 is imaginary part of x. Okay, real part of x and imaginary part of x. Fine. So iota square is -1, right? Then what is iota cube? It is nothing but -1 into iota, or it is nothing but iota square into iota, which is -1 into iota, which is minus iota. So iota power 4 is iota square whole square. It is -1 whole square. It is 1. Fine. So iota power 4 is equal to 1. And iota square is equals to -1. Iota cube is equals to minus iota. Suppose I ask you to find the values of iota power 25, iota power, say, 2021, iota power 2019, and iota power 2020. Okay. So then iota power 25, you can write it as iota power 4 into 6 plus 1. Okay, I'm dividing this 25 with 4 because this is iota power 4 into 6 into iota, and this is iota power 4 whole power 6 into iota, and iota power 4 is nothing but 1. So this is 1 power 6 into iota, which is iota. So iota power 25 is iota. and iota power 20, 21. You can write it as iota power 4 into 505, right? Plus 1. So this is also iota because this is a multiple of 4 plus 1. Iota power 2019, you can write it as 4 into 504. It is 2016 plus 3. So this is iota power 4 whole power 504 into iota cube. This is 1 into iota cube, and iota cube is minus iota. Iota power 2020, it is nothing but iota power 4 into 505. So this is iota power 4 whole power 505. So this is 1. Fine. So iota power 4n plus 1 is nothing but iota power 4n into iota. This is 1 into iota. This is iota. And if you have iota power 4n plus 2, then this is minus 1. Iota power 4n plus 3 is minus iota, and iota power 4n is 1. Here n is what? N is a natural number. Fine. Or also, I mean, you can take whole number. So n is a whole number here. Fine. So we have just given a basic introduction of what is a complex number, because while solving a quadratic equation, you can have complex numbers as roots. So that's why we have just discussed the basics of complex numbers. We will be using this. Actually, we'll be using this in algebra. So in some expressions, if we put x is equals to iota, then our task will become very easy. So we'll be using this in algebra. So I mean, just try to understand the basics of complex number. So I mean, we are discussing the basics of everything. Okay, we have discussed the basics of binomial theorem. We are discussing the basic of how to solve a quadratic equation, and we are discussing the basic of complex numbers, and we are also going to discuss the basics of arithmetic progression, geometric progression. Fine. So we are just giving a basic idea of everything, and then we'll move to number theory. So that when we move to number theory, then I mean, you should have idea of all the basics so that we can solve the problems easily. Fine. So this is about iota. Say now there is one more thing, that if two complex numbers are equal, say x plus iota y is equals to a plus iota b, then this is true if and only if x is equal to a and y is equals to b. That is, their real parts and imaginary parts should be both equal. So if two complex numbers are equal, then their real and imaginary parts should be equal. Then their first condition, real parts should be equal. Real parts should be equal. And second condition, imaginary parts should be equal. Fine. So if two complex numbers are equal, then their real and imaginary parts should be equal. So say if I have x plus iota y is equals to 0, then this simply implies that x must be 0 and y also must be 0, because this is nothing but 0 plus 0 iota. So x is 0 and y is also 0. Fine. So I mean, for now this is sufficient of complex numbers. So in the next video, we'll discuss the basics of arithmetic progression, geometric progression.